Hi, I'm Joe Justice, and I'd like to talk to you about Agile hardware. Agile executives get it. All around the world, top executives are linking agility to faster delivery of new product development and new product introduction. From Volkmar Denner, CEO of Bosch with 300,000 employees worldwide, to Akio Toyoda, CEO of Toyota Motor Company, Herbert Dies, the CEO of Volkswagen Group, and Elon Musk, who I worked for, they all map agility directly to speed of execution and speed of execution as the highest priority for the company. And that's no surprise because mapping speed of new product development and new product introduction in hardware, we call that NPD and NPI. The faster that rate of change, the higher the company is valued on the global financial markets. Tesla, for example, famously deploys more than 27 changes in hardware in production every day. And they have the highest publicly traded value by proportion. And you see slower companies, slower product deployments have lower values. This isn't just true in publicly traded companies. We're seeing this in government entities and public-private partnerships all over the world. The US Department of Defense, the Australian Department of Defense, Lockheed Martin, Raytheon, Google, Amazon, Microsoft, Boeing, HP, etc., all have well-developed, well underway Agile initiatives in areas or the entire companies. Depending on how you measure it, the majority of the world's money is managed under an Agile transformation. Royal Bank of Canada, with 7,800 employees, has assets under management of 660.9 billion Canadian. ING Bank has 54,000 employees and 887 billion euro assets under management. Pictet Bank, the largest privately held bank in the world, just under 5,000 employees, assets under management, 544 Swiss francs. Capital One has $372.5 billion US assets under management and just about 50,000 employees. What these companies are doing inside, especially in hardware, looks a lot like the Spotify model. Henrik Nieberg years ago famously said, don't call it a model. This is simply a snapshot in time of what Spotify was using at the time. And in fact, now they've evolved and are doing something quite different. Well, that said, this model works really well and is very similar to what's happening in hardware. You have the product, the hardware, and it's split into modules that can be built in parallel. If you have one car and it takes 5 to 7 years to design and deploy and release a new car, which is very normal for Daimler or BMW or Toyota or Ford, if you can cut the car in half and build both those halves completely independently because they have a stable interface, they know how they're going to connect, maybe you can go twice as fast. Well, if you can cut it into 8 pieces like Wikispeed does, maybe you can go 8 times as fast. Then you have Agile teams with full ownership of each module working in parallel, and that speeds it up more, which is something Agilists around the world are famous for. Now, that does mean each of these modules operates like it's its own company. It has its own procurement, its own financial book of business, its own internal accounting, its own electrical engineering, its own mechanical engineering, its own software engineering, etc. They have their own prioritization, which I'll call the product owner function, and they have their own impediment removal, which I'll call the Scrum Master function. This is also very similar to what Paul Tacken rolled out across ING Bank. I haven't yet had a need for tribes or guilds in hardware, but maybe that's where this will take us. What I have had a need for is communities of practice. Since each of these module teams has their own electrical engineering, their own mechanical engineering, etc., in order for these disciplines to stay aware of the state of the art and share tips and tricks and tools and automation, primarily automation, with each other, they do meet in communities of practice or quality circles. This is becoming so common that government regulation agencies are recommending it now. In the United States, the Food and Drug Administration must approve embedded electronics, medical devices that go inside the human body, and medicines. They do still publish a waterfall diagram of big planning up front of how to have these devices approved for use in the human body and on the human body. If we read the law, however, they're already recommending concurrent engineering and iterative engineering. In fact, the FDA is so bold, the Food and Drug Administration in the United States is so bold that directly in the federal law, it says waterfall, big planning up front, is only appropriate for the most trivial devices. For more complicated devices that have higher utility, we need feedback paths between the previous phases representing the iterative nature of product development. They then say the device file, which is how the manufacturer of the part or good shows what process they used, whether it was waterfall, whether it was Kanban, whether it was lean applied to Scrum and lean systems engineering, or whether it was another agile method. They say the primary consumer of that device file is the company making the product itself and not the regulatory body. Yes, you're required to document how you made it, but the consumer of that document is primarily you, to show that you had a method, not to say it had to be any specific method. And now there are published guidelines on Agile in the FDA and other regulated environments. The FDA is not alone in this. We're seeing this in aviation approval, aerospace approval. Tesla has completely disrupted automotive approvals, so they're able to have multiple approvals a day for new hardware. And so automotive spice fits in this, etc. Volkmar Denner, chair and CEO of Bosch, called my mobile phone directly. I was thrilled by this. I was starstruck. Thank you so much, Volkmar. And he says, for Bosch, agility is crucial. It allows us to adjust to the increasing speed of the world around us. Agility allows us to remain in a position as an innovation leader. And here's how this works at Bosch. I had a one-on-one session directly with Volkmar. Then Volkmar had me give a keynote to all of the top executives at Bosch. Now, Bosch is more than 300,000 employees, so there are 500 top executives. So I did a keynote style delivery and then worked with all of them in small groups on their agile transformation. Then I worked with product teams. The picture in the left is an actual Bosch product attached to a freight train. So this is a commercial train in the train yard with a Bosch rangefinder attached. And at the end of 1 week sprint, there is hardware with software on the customer's product being tested in the field. And here are the next 4 sprints. The sensors needed a more clear picture of the world around the freight train. So a clear window was installed, but weather was affecting, rain and snow were affecting the sensor performance. So a wiper was installed. In sprint 3, 1 week later, a larger screen was attached, so even more sensors could be positioned, and a larger wiper, updated software, updated electronics. In sprint 4, there's new circuit boards made in-house and ordered from out of house, installed in a smaller enclosure. The enclosure is now made in-house. Even the wiper is 3D printed. By sprint 5, the software and sensors are working well enough together. They no longer need a screen. The software and the sensors compensate for the enclosure, and they no longer need a wiper. The product was good enough. It went for sale. The point I'm trying to make, a sprint in hardware does mean it is deployed and it is being used by the customer for real feedback. And these are 1 week sprints, and in 5 sprints, hardware, software, electronics are deployed to complete the products for sale. Here's what it looks like in manufacturing. This is in Tesla, where I was working. I don't get to share pictures from inside Tesla, but Elon Musk shared this picture, so I can share it and talk to it. Here you see the Tesla Model X body being put together. This is the body in white process. There are more than 27 changes made to this product a day in production. So how does mass manufacturing look with Agile hardware? Well, it's robotic integration. The robots have flexible hands, so they can hold different parts because they're getting different parts 27 or more times a day. So the robot hands need to be programmed to hold the different part, and then they connect them. Next, the mating surfaces on the parts have known stable interfaces. You can see they're mostly flat to simplify the mating, the connection of the parts, but they're not all flat. As long as the interface is the same, the rest of the part can change as many times as it wants, and the parts will still connect. Now, that said, the interfaces in practice do change, and very often. The teams working on all parts that share an interface need to agree when the interface will change so that the car will still integrate and pass integration testing. Automation in software and hardware and management with test in the loop is, in fact, the answer. Humans are for creative problem solving. Automation is for everything else. And the picture in the inset is me working at Tesla's global headquarters in Fremont, California, United States, where this picture was taken. In traditional manufacturing, if we look down at the manufacturing facility, the factory, you see trucks unload stock and it flows in what's called single one-piece continuous flow as the product is built by aggregation. Then for final testing, it's brought into a test laboratory, or typically 1 out of every 1,000 parts is brought into a test laboratory, and then it's brought in trucks for deliveries. This is the aspiration of the Toyota production system. The Toyota production system strives for single one-piece continuous flow. The challenge is, if you make a change to what's being produced, each step potentially in this flow needs to be reevaluated and retested. So change is expensive. If we want agile hardware, if we want fast, rapid, inexpensive, low-risk change, we have a very different structure. We have what's called a stock backplane. This is a wide fanning out warehouse with people pulling carts of product or automated trolleys. Those parts are then shifted in real time to where they're needed. There's not single one-piece continuous flow. It's too slow for new product introduction and new product innovation. Instead, parts come on demand and what comes changes more than 27 times a day. Those are then brought into cross-functional teams that do design, manufacturing, engineering, and the prototyping, manufacturing, and deploying to the prototype line, which are in fact the prototype line. So stock flows from the stock backplane. It's built in modules in parallel, and that flows to what's called the stock front plane, which is the integration point. All teams must connect their products into all the other modules before it's considered done. So the definition of done for leaving these Scrum manufacturing steps is verifying all unit tests pass and integration tests pass. Now, you don't need external testing anymore. So for legacy buildings that already have legacy testing buildings, they have an opportunity to give back to the community by setting up something like an Edge of Scrum school. For details on exactly how this works, I highly recommend Paolo Samichelli's book, Scrum for Hardware. The second half of the book is the technical practices that make agile hardware work, which I'll call extreme manufacturing. This works in construction as well. During COVID-19, hospitals were asked to be increased in capacity and built entirely new in 3-week sprints. Companies that previously had said they can only manufacture in multiple year cycles started deploying hospitals in sprints. The method to do that is modules at a time that are complete, including heating, ventilation, air conditioning, and cooling, HVAC. They're including operational hospital beds. They're full functional hospital units. They're not isolated components. Those are built in 3-week sprints or faster. Then those are stacked side by side and stacked on top of each other. And this is, of course, how agile companies are building their factories now. Here is Tesla's Gigafactory in Sparks, Nevada. You can see the cubes that compose the factory, and the factory is not all built. It's not its final shape. It's going to be a very large, mostly rectangle. And you can see here, not all of it's built. As the next cube is being built, work is already being done in the previous cube. This allows for an earlier time for functionality in the facility. In fact, it's even more aggressive than that. As soon as the property is owned, tents are erected and manufacturing starts in the tents. then the building in one cube at a time, a module XY, is built over the tents, and then the tent is taken down and manufacturing starts working in the cleaner environment of the factory cube. That's while the next factory cube is being built and it's deployed in module XY. Now, the next step is what's called modular Z construction. You can see that in the inset picture. Here is an operational office at Tesla's Fremont headquarters, and another building is being built while the lower office is being used. There are also tents around it where even more work is happening. Peter Stevens and I have had a very fun Twitter exchange, and one of them is, you don't have to exchange flexibility or for predictability if you have known stable interfaces. This, of course, works in aviation, and I've had the privilege to work with the F-35 Joint Strike Fighter team, the F-22 Joint Strike Fighter team, and the Saab Gripen Joint Strike Fighter team. And when you're building a product in 3-week sprints like Saab does with the Gripen, now other agile practices like having customer on site make sense. If you have an 11-year product development cycle, there's not much to keep the customer interested over 11 years. But if you're deploying updates to your plane in hardware and software every 3 weeks, other agile practices like customers on site make perfect sense. That feedback speed matches. So Saab has 8 pilots on site full time. Again, the first method to get a radical increase in speed in hardware is to take extra large projects and split them into many small and extra small projects. In this way, the agile architecture of the system is the gating factor for speed. This only works if the modules are able to be executed in parallel. For that to happen, they need a known stable interface. This is exactly what SpaceX does. Here is the sprint review of the Falcon Heavy as its side boosters are landing simultaneously. And the inset picture is me at SpaceX global headquarters in Hawthorne, California. The Falcon Heavy rocket, which is an extra large project, is 3 medium projects: a side booster, and a center core. Those are all Falcon 9 rockets. A Falcon 9 rocket is composed of 9 Merlin engines. A Merlin engine for SpaceX is now an extra small project. They make new Merlin engines every single week, and every single one is an improvement or an attempted improvement on the version before. Elon Musk famously said, "We've never made 2 engines the same." And it's true. It's a constant stream of new innovation. So you have 27 extra small projects, none of which are redundant. It's not, innovation never stops. It's constant deployment of new hardware in this production line of these 27 Merlin engines. Once there are 27, they're composed into 3 Falcon 9s, and when 3 Falcon 9s are composed, they can be composed into a Falcon Heavy. And this is how they launch new rockets in less than a week. This is exactly what the Standish Group has been trying to teach us since 1985. The Standish Group tracks project success across hardware, finance, software, furniture, medical devices, and others. They track them all over the world. A primary metric was the project big planning up front with one attempted large deployment, or was it a sequence of small projects with small deployments that add up to a large deployment? That we'll call waterfall, big planning up front, versus agile, permission to change in small projects. Large waterfall projects are complete and total failures 42% of the time. All money spent, nothing ever shipped. Versus small agile projects are on time, on budget 58% of the time. The risk mitigation strategy is split the large projects into small projects and execute them in agile methods. That's exactly what agile hardware is. I highly recommend Paolo Samichelli's book, Scrum for Hardware. You can download a free preview at the link on your screen. Please take a screen capture or a photograph. I would encourage you tonight to read page 13 and 14 of the free sample. I think that will get you started on exactly how this agile hardware stuff really works. I'm Joe Justice. I'm the author of the Scrum Hardware Guide. I am currently the chair of the Agile Business Institute and the creator of the Extreme Manufacturing Methods. To sum up my approach of what seems to actually be working is Morale multiplies velocity. And so much of what this actually is about happiness throughout the organization and our supply chain. Second, the business mind that seems to work the best. If we're not growing, we're dying. And third, the method to get speed and reduce risk in hardware. An extra large project is really 18 extra small projects waiting for modular architecture. In summary, hardware can be deployed in mass production more than 27 times a day. And when that happens, all of the agile practices and mindset fit perfectly. Have an awesome day and enjoy Experience Agile 2020.